Okay, so now that we've talked about the rules and we've also talked about how to set the problem like this up, let's go into it and actually figure out what the two fractions would be that would form this one. Alright, so the first thing you want to do is we need to see which one of these three rules that we're going to apply. So this problem, this can actually be broken down into 5x plus 27 over x plus 3 and x minus 3. Okay, so that can be factored. So if you can factor something, then definitely you're not going to use rule number 3, because rule 3 only applies to irreducible polynomials. So this one actually looks like it's going to turn into rule number 1. Now rule number 1, let's go ahead and set this one up. So here is our problem we begin with. We're going to set that equal to the setup, a1 over x plus 3 plus a2 over x minus 3. That's basically the way we're going to break this up. So I have each one over its own linear factor. There's however many fractions you have matches however many of these you have on the bottom. So that's going to be our answer for that one. Now, next thing what you want to do is you want to actually do the work and combine these together as a single fraction. This one over here, I'm just going to go ahead and leave that alone. So 5x plus 27 over x plus 3, x minus 3. Okay, so this, I need to get common denominators with each one of these. So I have a1 over x plus 3. It has the x plus 3, but we're missing the x minus 3. So I'm going to go ahead and multiply top and bottom by x minus 3. Next, I have a2 over x minus 3. I'm going to multiply this one by what it's missing. In this case, I'm missing the x plus 3 top and bottom, so I have that one. Okay, so now that I have this complete, when I multiply through, the bottom ones are already going to be equal. I've already made this, all the bottom fractions the same. I'm not going to worry about the bottom anymore. I'm only going to focus on the top. So I get 5x plus 27 is going to equal a1 times x minus 3 plus a2 times x plus 3. So I get down to this. So again, I don't need to worry about, the reason why I'm not worrying about the bottom is because those are all equal to each other already. X plus 3, x minus 3, that's exactly what I have on the bottom of each of these fractions here. So that's why I'm ignoring the bottom. I'm only focusing on the top. So every single time you do a problem, you're always going to set it up and you're always going to do this step to bring it down to here. Now, once you get to this step, you can kind of reach a crossroads. At this point, we actually have a couple different ways that we could set this one up and solve it. I'm actually going to show you both methods for this example of how to solve that. So, what we'll do is I'll do 2 different videos to show you each one, and I'll connect them all together. So first, let's go ahead and do the first method. Okay, we just worked through this problem and we got this equation. This is our original setup, and we did common denominators and got that. Now that we've gone through those steps, we need to look at our 2 different methods for solving for a1 and a2. So no matter which method that you pick, you still want to use this line right here. So this equation that you got by doing common denominators, you want to do that no matter which method that you want to use. So let's look at the first method for solving that. This is called the equating coefficients method. What this involves is you're going to actually match up coefficients on each side. So in order to do that, we have to actually free up the parentheses here. So I'm going to go ahead and multiply this out. a1 times x minus 3a1. And then plus a2x plus 3a2. So I've multiplied all that out. The next step, what you're going to do is you're going to match up the common coefficients. So I'm going to put the like coefficients together. So I still have 5x plus 27. I have the a1x and a2x. Now if I put those together, what I can do is I can actually factor out an x from both of those, and I get something that looks like this. I end up with a1 plus a2 times x, and then over here I have minus 3a1 plus 3a2 over there. So what I'm going to do is I'm going to take these two here, and I'm going to match these up with the coefficient of the x. So a1 plus a2 can be matched up with the 5 because these are the common coefficients. That's what we mean by equating coefficients. You're setting them equal. Now by doing that, I'm going to end up with this equation, a1 plus a2 is going to equal 5. And then what I'll do is the part that's over here, these are the non-variable, these are the constant terms, and I have 2 of them. I only have one of them over here, so basically these two guys here, the negative 3a1 and 3a2, that has to add together to equal to 27, so I'm going to be able to get another equation out of that. So I'm going to write negative 3a1 plus 3a2, and that's going to equal 27. Now what I end up with is two equations and two unknowns. I need to solve this by using either substitution or elimination techniques. So probably elimination is going to be the best in this case. And I'm going to eliminate the a1's right here. So by doing that, I just need to multiply the first equation through by 3. If I add it to the second equation, that'll allow me to cancel out the a1's. So notice that when I wrote these, I made sure that the a1's were lined up together and the a2's are lined up. So you want to make sure you do that too when you do these. Multiply the first equation through by 3. We get 3a1 plus 3a2 is going to equal 15. Down below, negative 3a1 plus 3a2 equals 27. The bottom one I didn't have to multiply by anything because already if I add these together, I'll get one of the variables to cancel. So in this case, I only had to multiply the first equation by 3. Now when that happens, when I cancel that, I get 6a2 is going to equal 42. And then I just got to divide both sides by 6, and when I do, I'll get the first answer, a2 is going to be equal to 7. So now that I have that complete, I can go into the first equation and put a 7 in there for a2. And if I do that, I have a1 plus 7. That's going to equal 5. When I subtract, I get a1 is equal to negative 2. So now I have a2 is 7 and a1 is negative 2. Now how do I write my answer? We go back into here and we're just going to replace a1 and a2 with the two numbers that we found. So that would get negative 2 over x plus 3 and then plus 7 over x minus 3. And it doesn't matter, we could switch the order on these, and that's 7 over x minus 3 minus this term. That doesn't matter, but the main thing is our answer is going to be written this way as the two fractions. So we took the original one here, 5x plus 27, x plus 3x minus 3, we broke it up into these two fractions. If we took these two fractions, add them together with common denominators, we would go back to where we started from. We get back over to this term here. So all we're doing is we're taking the combined fraction and splitting it up into two separate fractions. So now that we've looked at the equating coefficients method, now let's take a look at the second method, which is called convenient values method. Okay, here's the second method, convenient values. What this involves is you're going to pick a number for x and you're going to put it into both sides of the equation. Now whatever value you pick for x doesn't matter. You can pick whatever you want. If you want to put in 1,000, you can do that, or pi, that doesn't really matter. However, we probably want to pick some values that would be considered convenient. What I mean by convenient is ones that will allow us to cancel out one of these variables. Because again, the end goal here is you're trying to find a1 and a2. So if I pick a value that cancels one of them out, then I'll be left with only one variable that I can solve for. Whatever you pick for x, you want to put it in for all the x's on both sides of the equation. And you can pick, again, whatever variable you want to use. First, I want to pick a value that will allow me to cancel out this a1 term. So particularly what you do is you look at inside the parentheses and you pick a value that will cause the parenthesis part to end up equaling a 0. So if I put a 3 in here for x, that would knock out that term and that would allow me to solve for a2. So I'm going to go ahead and pick that value first. So again, you're allowed to pick any value for x that you want, but purposely I'm choosing 3 because I know that's a convenient value to allow me to cancel this one out here. When you put the 3 in, you're going to put it in all the places for x on both sides of the equation. 5 times 3 plus 27 is going to equal a1 times 3 minus 3 plus a2, 3 plus 3. So if we do that, then what happens is I'm going to solve for it. I get 42. a1 is going to cancel because we have 3 minus 3 here, which is 0. 0 times anything is 0. And then we have this. I have a 6 here, so I can write that as 6 times a2. So when I divide both sides by 6, I get 7 for a2. And note that's the same exact value we got last time when we did the equating coefficients method. Now what we'll do is we'll pick another value for x. So again, I can pick whatever I want, but purposely I want to pick something that will allow me to cancel out the other variable. I've already solved for a2, so now I want to solve for a1. So if I could cancel out this term now, then that would be good. What makes this part 0 is going to be negative 3. So that's the next value I'm going to pick. That's my next convenient value. I want x to be equal negative 3. I'll put negative 3 into both sides of the equation. That'll allow me to cancel out the a2, and then a1 is the last one I want to solve for. So I have 5 times negative 3 plus 27 is going to equal a1 times negative 3 minus 3. And then I have a2, negative 3 plus 3. What will happen is this part is going to cancel out and give me a 0. This part, when I add it, negative 15 plus 27, that's 12, equals a1, and then that's going to be times negative 6 for this part. Then just divide both sides by negative 6, and then you get negative 2 is a1. So now I have my a1 and a2 values are exactly the same as before. So I would write my answer exactly the same as I talked about before. With the equating coefficients, you're just going to plug both of these back into here, remove the a1 and the a2 and replace them with these numbers. And that's basically how you can write that as a decomposed fraction.